Hello friends, good morning. Today we learn the 9th class mathematics chapter 5th Introduction to Euclid Geometry. We continue this chapter in this video. In this video we solve the example second. Second example is telling prove that an equilateral triangle can be constructed on any given line segment. Friends, in this problem is telling that an equilateral angle can be constructed on any given line segment. Friends, we take a line segment. Suppose this is a line segment A and B. Now in the statement give the a line segment of any length constructed an equilateral triangle. Now we construct a triangle on this line segment. We use the Euclid postulate 3 for this problem. कौन सी postulate? Postulate 3. Postulate 3 is a circle problem. Define. In postulate 3 is telling that what telling? Three is telling that if equal are subtracted from the equal, the remainder are equal. Now, and we take a postulate number 3. Postulate number 3 is given that a circle can be drawn with any center and any radius. A circle can be drawn with any center and any radius. Friends, now we construct a circle through this line segment. How? First we also draw a line segment. Now we draw circle. How? We draw a line segment this A and B, and we assume that A as a center and AB as a radius. AB as a radius. We assume that A is a center and AB as a radius. For construct a circle, we need only two things: a radius and a center. From the center A, we can draw a circle. This is circle we draw from B. Now from B we draw a circle. How? We consider B as a center and BA as a radius and draw a circle. How? This type. The circle is cut at the point C. Circle is cut at the point C. Now we join the point C to A and B. A and B. Now AC and BC also radius. AC and BC also radius. AC equal to A, B, and AC is equal to AB and BC is equal to BA or AB. So we telling that AB equal to AC equal to BC. So we telling that AC equal to AB because it is radius. And BC equal to BA also radius. So radius of the same circle. So we telling AB equal to AC equal to BC. So we telling that triangle ABC is an equilateral triangle. Now we take example number 5.9. Example is finished also. we take theorem 5.1. Theorem 5.1. Theorem 5.1 is telling two distinct lines cannot have more than one common point. You see, in Theorem 5.1, two distinct lines cannot have more than one point in common. Friends, in this postulate, we assume two lines. In this theorem, in this statement, for this statement proving, we assume two lines L and M. Friends, we prove that these two lines passing to two distinct points. Friends, suppose two distinct points is P and Q. P and Q. If this line is passing through two distinct points, then that statement is false, or that theorem is false. If these two lines is not passing two distinct points, then this statement is right. Yeah, true. Friends, two lines passing through two distinct points P and Q. But if we assume this statement is true, then the assumption clashes with the assumption that only one line pass through two distinct points. If we assume that if two lines is passed through to two distinct points, then assumption is clashed with the axiom that only one line is passed through the two distinct points. So the assumption that two lines cannot be passed through two distinct points, because the assumption, Euclid assumption that only one line, assumption क्या है, assume क्या है, only one line can pass through two distinct points. But in this theorem, it telling two line pass through two line cannot pass through one point in common. So friends, two line cannot pass more than one point in common. Friends, you understand now that from two